Let us take some examples to see how can we solve or find the initial and final values. For example, this circuit, if we take it outside like this, and I want to find the initial values and final values. So the initial value is the same circuit, okay? Switch was on, so this means that we need to remove the switch here and connect it so to look like this. So the switch was on, simply on. Okay, so when it is on, the capacitor is open circuit because this is a DC. The capacitor is open circuit. So this is open circuit. And the inductor is short circuit. So here it is. The capacitor is short circuit. The inductor is short circuit and the capacitor is open circuit. Of course, when the capacitor is open circuit, this means that this resistor here has no value because it doesn't have any current. So here, if you have a current like this, the current will continue like this. So you can calculate this current very easily. It is just 10 volt divided by the resistance, which is 4 plus 6, which is 10. So the current is 1 ampere. 1 ampere. So I of 0 is 1 ampere. Is 1 ampere. And V of 0 is the voltage between these 2 points here, this one and this one here, this point. But since you don't have any voltage here, you can say that it is the same point. So, or you can just leave it like this, as you like. So you can say this point here or this point. There's no difference between them. So actually you are calculating the voltage between this one and this one here, which is the voltage across the 6 ohm. So you can use Ohm's law. The current here is 1 ampere. This is the current in the 6 ohm is 1 ampere. So the voltage will be what? Will be I times R, then V0, which is the voltage across the 6 ohm. That's 1 times 6 will be 6 volt. Okay, this is 6 volt. Next, we need to calculate the derivative, the first derivative. So let us look at the circuit here after you turn on the switch. You turn off the switch. It is this part. So this part here. Here's the switch. Don't need it. You don't need this part here. So the circuit is not connected to the source here. And you want to calculate VC dot. So let's use a different color. V dot or dV by dt and I dot of t. Okay. So as I said here, what is V? dV by dt for the capacitor is you can get it from the current here, IC. So I want to calculate the current IC. This is IC. It is IC divided by C. And for I dot, the current, for the current in the inductor, it is a voltage. This is VL. So it is VL divided by L. So this is a voltage across the capacitor derivative, and this is the current derivative of the current in the inductor. Okay, so we need to calculate final IC at time of 0 and VL at time of 0. IC equal what here? When you change, when you disconnect the switch, the current here was what? Was 1 ampere. The current was 1 ampere. So this is still 1 ampere for sure. So at t equals 0, the current here is 1 ampere. And V0, this one voltage here, we know that this one is 6 volt. Here it is. So we have to use these values here. These two values, 1 ampere and 6 volt. 1 ampere and 6 volt. This will not change. at t equals 0, it will remain the same. Okay. Then we need to calculate IC. What's IC? IC for sure it is -1. Why? Because this current here, 1 ampere, will continue in this direction like this, clockwise, and IC is counterclockwise. So IC equal -1. IC equal -1. So it will be -1 divided by C, which is 0.02. 0.02 farad. This is C. C is 0.02 farad. So this equal -50. -50. For I dot, you need to get it from VL. So I need to find VL. This VL at time equals 0 equal what here? I don't know what's the value here. To be honest, we need to calculate it. Okay, so here we have a loop. So we use Kirchhoff-Voltage law, Voltage law. So we have voltage across the inductor. This is what we need calculate, and we need to calculate other voltages here. We know this one is 6 volt. Okay, what about the voltage across the 6 ohm and the voltage across the 3 ohm? We know that the current is 1 ampere. So if the current is 1 ampere, we know that the voltage across the 6 ohm will be 1 times 6 will be 6 volt. So you have 6 volt here. Positive here, negative here. And also the same, the current will continue this direction, 1 ampere. So it will be also positive, negative 3 volt in this case. 3 times 1 will be 3. So now we know all the voltages. So what we need to do is to calculate this VL. So you can calculate VL very easily, because you know that VL, if you assume that you using the clockwise direction as a positive direction, this one here is in this direction. The voltage from negative to positive. VL is the same. Okay, this 3 volt is the same in this direction. 6 volt, this 6 volt is this direction. So if you assume that the clockwise direction is a positive, then in this case VL is negative, and 6 volt is negative. I'm talking about the voltage here, this one. So this one is negative, this one is negative. 3 volt is negative also. And the voltage across the capacitor will be positive. 6 volt equals 0. Why again? Because you are talking about the voltage in this direction, in the clockwise direction. In the clockwise direction. So you are talking about direction like this. So you see you are moving like this. So it is opposite to this is 6 volt, opposite to VL, opposite to the 3 volt, in the same direction of the 6 volt. So let me erase this one here. So from here you can calculate VL, of course, because this 6 cancel with this 6. Then VL is -3. VL is -3. So this will be -3 divided by L. What's L? L is 0.5. Given here, 0.5. So -3 divided by 0.5 is -6. Finally, we need to calculate the final value, which is very easy. IL with infinity and V of infinity, both of them are 0. Why? Because we will have this circuit here, this circuit, this circuit, the same with me, this part here, this circuit. Do we have any source in this circuit? No. So the final values, what do we expect here? The voltage across the capacitor was 6 volt. The current in the inductor is 1 ampere. But in the long term, of course, all this will die because you don't have source. Don't have source. So it will be 0 and 0. That's it. This one is 0. This one is 0. So this is the solution of this example.